Hi, Algebra 1. Welcome back to class. This is our last week of Algebra 1 for this school year. This is the first of 3 lessons that we're going to cover this week, and I'm really excited to dive in and get started. So today's lesson will be the second half of 10.4, and we're going to be talking about solving our radical equations that we started last week on Friday. What makes today different is that we're going to see different situations that happen with our solutions. Now remember, anytime we solve an equation, the last thing we should do is to check our answers. So you're going to see today that once we've gone through the algebra of solving these equations, when we check our answers, we're going to see an interesting thing happen. Okay, so this is our first example right here in the blue. N equals the square root of n plus 12. By the way, we're on page 622 in our books, and you still have a note handout available for you on RunWeb. Okay, n equals the square root of n plus 12. Well, as we go through this one, I'm going to review the steps that we learned on Friday for how to solve a radical equation. For this one, remember, the first step is to isolate the radical. Means get it alone, get it by itself on one side of the equation. Well, as you can see, this radical is already isolated. So we're ready to jump to step 2. And that is to undo the square root, we have to square the radical. Well, we say square both sides because we know our rule that when we're solving equations, we can do whatever we want to them as long as we do it to both sides. So I need to square that n on the left side. Let me write where we are at this point. Now I have n squared equals n plus 12. Because when we square a square root, we eliminate the radical and we are left with just the radicand. Well, on Friday, we would have just continued solving this equation for our variable. However, you probably noticed something different about today's equation. What this one leaves us with is a quadratic equation. So we need to think back to last chapter, our last quiz in 9.4, when we learned how to solve these, when we use factoring to do so. But before we can even factor to solve them, we need to get them in standard form. Everything on the left side of the equation set equal to 0. In order to do that, I need to move my n over by subtracting it, and I need to move my 12 over by subtracting it. Now I have this in standard form. Now I'm going to go ahead and factor and solve. Well, the nice thing about this particular problem is this lead coefficient is a 1, so it means all I need to do is think through an x form. The negative 12 goes in my ceiling, negative 1 goes in my basement. So I think through my factors that get me negative 12, and I know it's going to be negative 4 and positive 3. So when I write this in factored form, this is what I get. And this is where I set up my 2 mini equations. So you see, at this point in the lesson, we are pulling in so many of the things that we have learned thus far during distance learning. I'm going to set this mini equation equal to 0, as well as this mini equation equal to 0. So that means for this, I get 2 solutions, positive 4 and negative 3. Okay. Remember when we learned about quadratic equations, we learned that I could get up to 2 solutions. So that is not weird that I got 2 solutions. But you'll see whenever I substitute those values back into my original problem, that something interesting happens. Okay, so let's do that with the 4. For the sake of space, I'm going just to talk us through it and we can do it mentally. If I plug this in, 4 equals the square root of 4 plus 12. Well, 4 plus 12 is 16, and 4 equals the square root of 16. Definitely true. So what I'm going to do, I'm going to put a check mark next to that one. That one checks out. I'm going to now talk myself through it, and I actually might write a little bit on the top for this one to show this. Okay, Now remember I said you can do this mentally, but I'm going to show you what happens here with this -3. I'm going to plug it in. -3 equals the square root of -3 plus 12. Okay, well -3 plus 12 is 9. The square root of 9 is not -3. That takes me back to principal roots. I know we talked about this at least once, and that is whenever we have the radical already in the problem, remember this problem had a square root in it, it is asking for the principal root, only the positive version of the answer. So the square root of 9 is 3, not -3. So that means that this -3 actually isn't a solution at all. Although we went through the algebra and we got it as a possible solution, it doesn't really check out when we check our answers. What that means is we got an extraneous solution. It means there's an apparent solution, but that actually doesn't really work. This is why we check all of our answers. It's almost like getting a false positive for a blood test. Let's say you thought you had coronavirus and you went to get tested, you got a false positive. It means the test showed you that you had it, but you really didn't. Somehow they would have figured that out. But it's like, you think it's an answer, but it's not. In some mysteries, we have, especially, oh my goodness, Agatha Christie. Agatha Christie, she's famous for having red herrings in her mystery novels. It means something in there that makes you suspect somebody else and think somebody else is the culprit when they're not. It's like throwing you off the trail. An extraneous solution is one that looks like it's a solution, but really doesn't check out. So whenever you solve these equations and you go through that checking process, make sure you go through the checking process, because our answer is not 4 and -3. We actually figure out that only 4 is the solution. Okay, so I want you to try this practice problem. It's the Got It problem under problem 4 in this section, and it's -y equals the square root of y plus 6. I'm going to clear my board just so we have enough space. You try this problem on your own, pause the video, and come back when you're ready to go over it. I'm actually going to move it over so we have lots of room. Okay, so here we go. This is the practice problem I wanted you to try on your own. Combines things that we've learned and how to solve radical equations, brings in our factoring from last chapter, but one thing that we need to be careful is that we are checking our answers and seeing if our solutions really do satisfy my original equation. Okay, I'm going to go through this one a little bit faster. Step 1 is isolate my radical. Already done. Step 2 is square both sides. So I'm going to square this side, and I'm also going to square the left side. I'm going to square everything on the left side because I'm the one through this process that is squaring this. So I'm going to use parentheses because whatever was on the left side of the equation needs to be squared, not just the y, but everything. So then what I get there is y squared, because the opposite of y squared is y squared. Just like if this was the number -1. -1 squared is +1. Okay. Just like our last problem, I now have a quadratic equation. I need to get everything to the left side in descending order before I can factor it. So that means I'm going to subtract y, subtract the 6, and set that equal to 0. I'm going to use my x form. I need two numbers that multiply together to get me -6, but add together to get me -1. So I know it's 3 and 2, but that 3 needs to be negative. That means when I factor this, I have this set equal to 0. So I set this equal to 0 and solve that mini equation, and this equal to 0. So my possible solutions for this problem are 3 and -2. And this is where we need to go back to the beginning. I'm going to use my eraser, if I can neatly do so. Squeaky squeakies. Okay. And see that this is my original equation. I need to plug these values in. I'm going to start with 3. So if I say y equals 3, that means I get negative 3 on this side is the square root of 3 plus 6. And again, I need to remember my definition of principal roots here. Square root of 9 is positive 3, not negative 3. I'm going to cross that one out. That one does not check out when I check it in the original equation. I'm going to do the same thing with my negative 2 and see what happens. If I say y equals negative 2, that means the opposite of negative 2 is positive 2. And underneath my radical symbol, negative 2 plus 6 is 4. Square root of 4 is positive 2. So while for my quadratics I can get up to 2 possible solutions, in this problem I only have 1 solution. And I don't find that out unless I'm doing my full process of checking my solutions at the end. Okay, the next example that we're going to go over looks like this. In this problem, I have the square root of 3y plus 8 equals 2. We're going to solve this problem following each of our steps that we've been going over to solve radical equations, and then we're going to check our answer back at the original spot. Okay, so my first step here, step 1, isolate the radical. This radical is not isolated yet, so I need to subtract 8 from both sides. I'm going to go back to using purple. So I have the square root of 3y equals negative 6. Step 2 is to square both sides. That gives me 3y equals 36, because negative 6 times negative 6 is positive 36. My last step is to divide both sides by 3. Okay, so I get as a possible solution y equals 12. We need to plug that back into the original equation. I'm going to do that in red. So y is 12. 12 times 3 is 36. And the square root of 36 is 6. 6 plus 8 equals 2. No, it doesn't. That's totally false. That tells me that y equals 12 is actually not even a solution at all. So if I only get one possible solution, and then when I check it, it turns out that's not even a solution, this tells me that I don't have any solutions. My empty set. I want to show you, though, how there's a part of this process that you would have been able to see that and not had to go through the entire thing. And I want to draw your attention back here to this step. I'm going to use my whiteboard eraser here to show you more specifically what I'm talking about. Before we squared both sides, this was our problem. Square root of 3y equals negative 6. Well, what did we just review about principal roots? When the square root is already in the problem, it is talking about the principal root, the positive version. So I can never have a square root equal a negative number. Right there, I could have just said, nope, impossible, empty set, no solution, no number in the world could I plug into that radical and get a square root that equals a negative number. It's not going to happen. Okay, there's one problem that I want you to try. Another version of this one, and it is the got it problem from number 5, and it looks like this. Let's see, equals 10. 6 minus the square root of 2x equals 10. Okay, I want you to pause the video and come back when you're ready to go over this. Okay, here's my radical. I need to isolate it. So I'm going to subtract 6 from both sides. That leaves me the opposite of the square root of 2x. Don't lose that, it's still there. Equals 4. Well, as part of my step to isolate my radical, I have a -1 as my coefficient of that radical, and I can't have that. So I need to divide this side by -1 and divide this side by -1. We know that that means we're just switching signs. So I get this situation right here. And as I pointed out with our last problem, here I can stop. I will never have a square root equal a negative number. So I'm done. Empty set. There's no solution here. Okay, now, if you would have kept going and solving this the same way that we've been doing, you still would have caught it when you checked your solution back in the original and it didn't pan out. Okay, that's it for today's lesson on 10.4. You have suggested book problems listed on RunWeb, and you also, instead of a Khan Academy assignment, there are even problems in the book that you are required to do and send to me by tomorrow, Tuesday at 5 p.m. And those are listed on RunWeb as well. And if you've noticed that my camera's been starting to fall a little bit and I'm a little crooked, it's because my tripod for my camera is broken and I needed to fix it and make it last one more week. And so it's leaning a little bit. I'll try to fix that for the next video, but there are no promises. So I hope, if anything, it cut out the top of my head. Okay, that's it for today, and I will see you back here tomorrow for one more lesson. 1 down, 2 to go for this week. Okay, guys, have a great afternoon.